So my name's Brian Fox. I'm the co-founder and CTO at Sonatype. I have a long history in open source. I was one of the early committers to Apache Maven. I was the chair of the Apache Maven project for a long time. I'm currently on the OpenSSF governing board and also the Finos governing board. So I don't write code as much anymore, but I try to spread the message and do a lot of work with policy and things like that as well. For some context, Sonatype has always been the company that runs the Maven Central repository, and so that's given us a lot of insight into a lot of things that go on in the ecosystem. Around 2017 or so, I started to see some new trends of things that were happening around what we now refer to as open source malware. So I've kind of been evangelizing this particular topic for a very long time. I think over the last couple of years, it's started to become more understood, unfortunately, because we didn't heed the warnings as an industry, and now the attacks are getting bigger and more prevalent. So when we think about what do we mean by open source malware here, I hate the word malware. I argue back and forth with my marketing team on this all the time, because when I say malware, everybody thinks like, oh, I have malware defense. I have protections already. There are vendors that do malware protection. And while that's true, predominantly what we're seeing on the open source side, it's not the same malware. So while technically it's malware because it is designed to do something harmful, and in this case, what we mean is components that were created and put into the open source supply chain whose sole purpose is to do something bad, right? I mean, that's like the definition of malware, but what we're talking about here are literally components put into NPM, into PyPy, into JRuby, occasionally into Maven Central, and they are masquerading as legitimate components. They're trying to get your developers to download them and consume them, and that's what we're talking about. And the interesting part, the struggle here, is that most of the time, the code that's in these components is not recognized by your traditional malware vendors, right? Because they're focused on things like viruses and rootkits and backdoors and things like that. Now, sometimes these open source components, they do use those things. And in those instances, the malware defenses would pick that up. But what we've been seeing over the years is that it's basically bespoke code. So it's like literally it's open source and it's malware and it's novel. And so like existing fingerprint detection techniques, they don't work on this. And so this is why we try to educate on this, because it requires different approaches, different sets of tooling, and it's hard for people to get their minds around that. So I'm going to keep hammering on some of those. I'll use some analogies towards the end when we talk about how we try to defend against it. But part of the challenge here is, of course, over the last decades, open source has continued to explode in terms of the prevalence and the consumption, right? So these are numbers from our yearly State of the Open Source Supply Chain report, 6.6 trillion components. We've seen a massive explosion over the last couple of years in terms of PyPI and this little thing, you might have heard of it, AI, right, driving a lot of this usage. But all of this usage is happening, and not all of it is sort of governed appropriately inside of organizations. And this is what the attackers have increasingly been exploiting. So like I said, all the way back in 2017, I started, speaking at conferences and trying to raise awareness. And it was interesting back then because like literally every week I had a new and novel attack that I would explain to people, and we were drawing a straight line, and I got to update the story literally every time I gave it. But it was a little bit quaint that I could talk about each individual one. Now we're talking about tens of thousands of these new components and attempted attacks happening like every single week. And this number is even out of date. Even though this slide was just created earlier in the week, I think the number that we have now is something like 850,000, right? And so this is across many different ecosystems. But these are the number of components that are blasted out there. Again, they have no legitimate purpose other than to steal data, steal credentials, drop backdoors, or what have you. And I talk to reporters, and they say, why is this happening? Well, part of it is we're not defending against it, right? Defense and security is a cat and mouse game, and so the attackers, they spend their time where they get the highest return on investment, just like we try to do. And so when they find a soft target, they just do it more and more and more. So the fact that this curve is still continuing to grow shows that we're not, as an industry, good enough at defending against this yet. What's interesting is back in October of this year, when our last report went out, we were covering some of the statistics, and one of the things that we looked at of all the components that are out there and all the different package systems worldwide, when we look at enterprise applications, only about 10% of those are actively used, right? So around 762,000 components are kind of the core set of what's out there in the world of open source that we see. And that's a big number. But what became profound to me at that time was in October, this number was around 760,000. And it was like, wow, we've already hit the point where the number of intentionally fake, malicious components that have been released in the world is more than the components that we are actively using every single day. So we've already crossed the point of the noise to signal ratio not in a good direction, right? And that happened back in October. Yeah. Basically, all of them are pretending to be something that looks legitimate, right? If they're a really terrible attacker, then they put something out there with a name that nobody knows about because they're not going to get any users. But most of these things use confusingly similar names. They replace an underscore with a dash, or capital with a lowercase, or what have you, right? And then they, in the early days we didn't see this, but we saw them adapt this behavior where they started scripting the downloads to drive the download numbers way up, and they'd script the stars. And so if you're a developer and you don't know any better and you search for a thing, you can't remember the exact name, you find this one and it looks legitimate. It's got all the stars, it's got millions of downloads, right? And so they get really good at faking these things, but the whole point is to trick you into it. So it's basically a modern day typo squatting attack, or another way to think about it is it's a phishing attack on your developers. So it's repo-based phishing, just like sending your mom a text and she's going to click the link because she doesn't know better. Same thing that's happening to your developers here with these components. So yeah, basically all of them. I would say the ones that aren't trying to pretend to be something is just like a really bad attacker, because who cares? And so we have had a couple of instances of intentionally malicious components published into Maven Central, but they looked to me like they were just sort of probing attacks for that exact reason. They were published in a namespace that didn't look like anything anywhere ever, just put in a corner of Central, and then they emailed me and said, hey, there's a thing out there. And so to me, it felt like, and nobody had downloaded it. It felt to me like somebody put it out there and then emailed us to see what we would do about it, right? So that's how it felt to me. But many of them are not in that instance. So I think it's interesting to understand now that like this signal to noise has already gotten upside down here. And because this number is continuing to grow, and like we're not gonna suddenly as an industry use 100,000 new components next week than we did before. This number, this ratio is only gonna continue to get worse. And so when we've gone to, one of our products that we have is Nexus Repository, and so that's a caching proxy. We have visibility into this, when we go in and we analyze organizations who haven't rolled out defenses for the malware, we find that about 50% of the times there are already some of these known malicious components that are cached inside of their repository, right? And so like we can't tell you if that attack was successfully exploited, like if any data was exfiltrated, but it's like finding a bullet hole in the wall of your living room. You shouldn't be okay with that. Somebody was shooting at you. That was a successfully delivered payload. Whether it was effective or not, you'd have to do your own investigation. So because the component didn't get into the cache by itself, it means at least one of your developers requested that thing to be pulled down. Right? So it's evidence of the delivered attack. And we're finding this more and more and more. And so, if we kind of take a step back and we look at the evolution of these attacks, in the early years, what we saw was the attackers were basically fast following public disclosures of vulnerabilities. So like one of the first, high profile open source vulnerabilities and fast follow attacks was the early struts ones. This one was not the one that became famous through Equifax. It was much earlier, didn't get a lot of attention. But I'm also a member at the Apache Software Foundation, and so I can tell you from the internal conversations, we saw that the bulk of the attacks that were happening were after the public disclosure, after the struts team fixed it, right? And then the attackers were fast following in days and weeks after that. And so in the early days, the conversation was largely around, you need to be able to update, you need to know that the things you're using have vulnerabilities, you need to update them faster, update faster than the attackers. That was kind of what was happening early on. We started to see this kind of perpetuate, and then, like I said, around 2017, coincidentally with the Equifax, is when we started to see this rise of these supply chain attacks. Now, the Equifax one was a little bit of a boring old vulnerability. Frankly, so was Log4Shell, right? There was nothing intentional about that. It was a combination of some features that led to some pretty significant outcomes, but it wasn't new and novel at that point. It was just last decade's war. What was happening simultaneously is that the attackers were, at that time, already releasing more and more of these attacks, these intentionally malicious ones, and refining their craft and getting much better at it. One that's sort of adjacent to this, you may have heard, was it last year already, 2024? The XZ utils attempted attack, right? Around the time of the summit last year is the thing that everybody was talking about. It was like, I did probably like 10 reporter interviews when we were in Seattle on this exact topic. So I guess it was basically a year ago. This was one where somebody, probably a nation state attacker, spent years working their way into a single maintainer project that happened to be really critical in the Linux infrastructure and was only somewhat accidentally discovered by somebody at Microsoft, I think it was, investigating why there was a performance problem in their component, right? So we got really lucky. I look at that and I think, there's 0% chance that there's not more of those out there. Like, think about it. If you were an attacker and they got access to the XZ utils like 3 years ago, I think it was, probably 4 or 5 years ago at this point, there's no reason why they would have said, yeah, we're good, we're going to stop at 1, right? So we only found out about it last year, but what have they been doing in the interim? So I think they're out there and we just don't know. In fact, I know of, because I helped investigate, at least a couple more that never became public that had very similar profiles. It was weird because it looked almost the same as XZ utils, but it looked like it was amateur hour. So it's almost like if these guys were working together, they handed it off to junior developers who had really terrible operational security and made a bunch of mistakes. But they tried to do the same exact thing that XZ utils did. So I don't know for sure if it's the same crew or not, but definitely there are more of them out there. Now, of course, with any new technology, we've got AI and the Hugging Faces repository. We've seen the attackers move into attempting to do some of the same types of things just more recently. We shouldn't be surprised about that, right? So they're looking at the fact that, again, just like the components in all of the other open source repositories, people are just grabbing them and downloading them. So if I can put something in there and slip it in, then profit, right? And so, there was the Nullify AI one, the pickle scan vulnerabilities, right? These are sort of combinations of age-old problems, right? Some of these were related to deserialization, unsafe deserialization. And in the instance that I put something in there, it gets deserialized, and then worse, it gets executed. It's a path to remote code execution. I put it in the model, and they were, in at least this last one, they were using some edge cases, I would say, in the scanner that was there to kind of hide. I think they used a different compression algorithm that wasn't considered by the scanning tool, and so it just sort of skipped over it. But fortunately, the researchers found it pretty quickly. So I think we're going to continue to see more of this over time. Again, like I said, it's working for them. These payloads are being delivered. What we know of, we had at least one large multinational bank who had an attack, but they didn't understand how the credentials were leaked. They didn't understand. They just knew that it happened, but nobody could figure out what the origin of it was. They rolled out our stuff, and they found that they had already had dozens of different malicious components. Some of them had actually got rolled out to about 40,000 production machines. So not only did it deliver the payload to the development machines, which is normally the target, it actually got all the way out to 40,000 servers in production. And they believe that that is actually how that other attack happened. They just didn't understand it because these things were in their system and they were completely blind to it. The other thing that was sort of interesting is they then took the technology and started scanning the software that they were purchasing from other vendors, and they found at least one other vendor had sold them software that included some of these malicious NPM components inside it, right? So it's very much a situation of if you don't have the technology and you don't have the data to know what you're looking for, it's right there, but you can't see it, right? Because nobody knows what they're looking for without the data. So when we think about the current breakdown of these types of attacks here, you know, a lot of them, you know, you can see there's a good chunk there. Data exfiltration, these are trying to steal, you know, API keys and cloud keys. And if you think about the development infrastructure, usually it's a very privileged type of environment. And this is why I believe they don't have to go so far as trying to create or leverage existing rootkits and things like that. They don't need to. The development machines, the build machines, they already have the credentials and the other type of data kicking around right in plain sight. So all they have to do is write some code that reads the environment variables, for example, or reads known files. You don't have to go so far as a sophisticated rootkit, you know, operating system type of attack, which again is why these attacks are all sort of novel, and also why your traditional malware vendors aren't focused on them, because every new one is different. There's no fingerprint to recognize. The lion's share of targeted malicious attacks, I mean, there's sort of the spray and pray attack that these folks are doing. They put them out in the repo, and anybody that gets them downloaded, it's just your typical phishing attack, and you might be an interesting target. There are a set of these that are targeted attacks. You know, so a handful of years ago, there was some research published. They called it dependency confusion. Right? So this was a case of understanding that if I know the name of an internal component that you have and I publish one to a public repository, but I use a higher version number, your build system might not be smart enough to only fetch your internal components from internally. You know, again, get a repository manager. That's what they do. We've solved that for 20 years. But if you don't have that and you grab it, then you're pulling down untrusted code from that public repository. So what we see in a lot of cases is some of these intentionally malicious components are kind of masquerading as these internal components. So you see the intersection of the namespace confusion or the dependency confusion with intentional malware being dropped on top of it, right? And they're targeting critical infrastructure. This really shouldn't be surprising to anybody at this point. You're going after the money, the government, and things that, you know, the public really cares about, right? That's where the attackers are trying to set these bombs. So when we think about how we defend against it, this is one of the things that I struggle with a lot, because I talk to a lot of really smart people, and I'll say, like, listen, do you have open source malware protection? And they'll say, yeah, we got malware protection. And I have to explain to them, like, yes, that's going to help you with rootkits and viruses, but it's totally blind to all of this. And I can give you real examples. I'll show you. I'll give you some of the stuff. Scan it with your tool. It's going to come back blank. And then they'll move to the next thing and say, yes, but I have a strong vulnerability reporting program. I scan my stuff, and you know, we fix our vulnerabilities, we prioritize them. It's like, you're doing all the things that you should be doing for managing vulnerabilities, and yet it's still not the way you need to defend against this. And so, you know, the analogy that I was using for a while is like, if I told you that, you know, you were at a party or you were here and the food was left out for a while and it was supposed to be refrigerated, it got warm, that's a vulnerability. It might grow some bacteria. That might make you sick if you were immunocompromised, right? It might be bad. You might look at that situation, if it had mold on bread or cheese at home and you were really hungry, you might say, you know what, I'm just going to cut it out and I'm going to eat around it. But I bet you in both of those cases, your response would not be the same if I told you that food was intentionally poisoned, right? You're not going to eat around the poisoned bread or the poisoned cheese, and you're not going to go, it's okay, you know, we'll refrigerate the food better, and that'll nullify the poison, right? And that's kind of the metaphor that's here. Like, the way you respond to a component that has a vulnerability, something that might happen, that might be a problem in your production, is one way. But when you're dealing with something that is designed to trigger and execute as soon as your developers download that component, it needs a different response, because by the time you prioritize it and try to fix it through whatever process you have days or weeks later, it's too late. Your data was sent out. If that payload executed, it executed the moment your developer downloaded it, right? So that means the only way you can defend against this reasonably is to get out in front of it. And so, you know, when you think about traditional scanning and things like this, what we're talking about is the packages are published into these repositories, And in many ecosystems that prefer downloading the latest, as soon as that thing hits the repository, you've got millions of builds that are downloading that. That's part of why they're doing this. They have a ready-made audience. They don't have to produce something that's going to live in the repository for weeks or months and have people, not knowing that they're using it. They get it out there. If it's out there for a couple hours, that might be good enough. They might have collected data from thousands of companies just in that couple of hours. And so, so the packages get released out there. Sometimes we find what's worse is when these get reported to the repositories, they get taken down, as they should, because there's no reason to leave it up. But if you actually have a repository manager and you're not cleaning the cache, it means that malware is now sitting inside your organization effectively indefinitely, because it's cached it now, right? So the fact that it got removed from the public repository doesn't always mean it gets removed from your internal repository. And this is why when we go and scan them, we're finding half the time those components are sitting there. They're echoes of that attack that happened at some point in the past, right? And so the way you need to be able to defend against that is by inserting something in front of that to be able to, in near real time, detect that these things are happening, detect that they are vulnerable, or specifically that they are malicious, and block it before the developer actually gets it downloaded. Right? And so that's basically how we've been trying to solve this problem for a very long time at this point. We're continuously monitoring the ecosystem. The way we do this is whenever components are published into the repositories, we're taking a look at those, and we've basically built behavioral models so we can understand that there's something fishy about this component. In retrospect, so this is a funny story. When we first built this and we were piloting it, I didn't know how many of these things were going to be out there. I didn't know if I was building the equivalent of like a global asteroid defense system, something that might only happen once a decade. And so we turned it on, we started testing it, and almost immediately we started finding these things, and we investigated a handful of them. And what we actually discovered was the researcher doing the dependency confusion research as he was doing it. This was 6 months before he published it. He left enough breadcrumbs in his work that we could figure out he was in fact actually a white hat, and we confirmed it. And so why did the system pick that up? Well, in retrospect, the behavioral model indicated that it's very unusual for new open source projects to publish their first version in a repo with a version like 1000. Like, that's not normal, right? And so after the research was disclosed, lots of tools created heuristics that said if the first one has a high version number, then flag it as fishy. But we didn't have to do that because our system was automatically recognizing these things as being different. And so we basically took a page from the credit card processing, credit card fraud industry. Like back in the day, they used to have, they used to ship books around when cards were found to be stolen. They would literally have a blacklist. They would ship it out once a quarter, and the vendors were supposed to check the credit card numbers in the book. Like, my mom had a business when I was in junior high, and I had to do this a lot. And then they got a little bit better, and they would scan it, and they would dial it up in real time. And so the turnaround time for blacklisting a credit card went from like once a quarter to like as soon as you called in, they could effectively stop it. And then, that wasn't good enough because there were all these fishy things. And, if somebody went in and got away with one transaction, they might steal $10,000 worth of technology and didn't care that the credit card got blocked. They already walked out with all this stuff. So I'm sure you've all had it happen to you. You do something with your credit card that, in retrospect, is not normal, and the transaction might get blocked immediately, right? Or you might get a text from your credit card company saying, this was fishy, was this you? Right? How are they doing that? It's because they understand all of us as stereotypes. They understand us as individuals. And so if we do something that's uncharacteristic, they block it and then reach out. And so that's kind of what we've been doing here, that we built all these models. We can't understand what the next new novel malware attack is going to look like, but we know what normal open source release procedures look like. When suddenly a project that is always released from California one day publishes a version from China, I don't know, that's kind of weird. It might be that person is on a business trip, but let's block that and do some investigation to confirm, right? That's kind of the behavioral analysis that we've taken to be able to identify that 850,000 and growing number. So it's been surprisingly effective at that. And so what we're trying to do is put that out there give tools the ability to basically have that real-time assessment. So we're able to assess within minutes of new packages being published to these repositories what their suspiciousness score is, right? And so with our products, we're able to block that if it's even suspicious. We send it to the research team. If they confirm it is in fact malicious, then it stays blocked. It's very rare these days that we find a false positive, but it can happen, right? And so that's kind of how we've tried to solve this problem. But the important part is for everybody to be aware that this is in fact happening. Just because you don't know that you don't have them cached in your repository or that your developers haven't downloaded them, if you don't have the list, if you don't have the tools to look for it, you can't know. You know, I live in New England. We have this thing that comes from the granite. It's called radon, right? It's odorless, colorless gas. It could still give you lung cancer after a while. Some houses have a ton of it. Without a radon detector, you wouldn't know it's there. Doesn't mean it's not going to cause you harm. And that's kind of what's going on with the open source malware these days. So that's kind of the end of my thoughts. Any questions? Yeah. Mm-hmm. And the LLM recommends more package that doesn't exist. Yeah. Because it's hallucinating. Yeah. And they squat on that. Yeah. Are you seeing more of those kinds of attacks? I have. I forget. What's the name of that type of attack? It's a slop squatting. That's it. Yeah. I knew it was something. That was inevitable too, and that was kind of smart on their part. I mean, you got to admire the game a little bit. Yeah. So. Are we seeing that more? I don't know if we're seeing it more, but I mean, more than zero is more, so it's definitely out there. And with any of these techniques, they never just stop. They only stop when we get really good at like defending them and it becomes unproductive. So until that happens, I would expect that that's going to be the case. And you know, with the rate that the LLM adoption is going and the AI-generated code tools, we should expect that those will happen more because there's going to be more opportunities for developers to just cut and paste AI-recommended bad component code.
Are there things you can do to make it harder for the attackers, such as putting your SSH keys in a non-default directory?
Yeah, I mean, all of the usual practices apply here, right? But it's sort of like, what's the adage? Like, you know, we have to get every single one of them. The defenders have to be perfect, and the attackers only have to be right once. And I think that's what's happening in a lot of cases. You know, you see people that accidentally check in their credentials in the source code, or they have them, the secrets are available only to the build or only to the production system. Well, guess what? That's where these components are going. And that's kind of the point to think about, is that the development infrastructure is a form of trusted execution. You know, and this can exist in the plugins. It can exist in any parts of the tooling as well. It's not just the dependencies. Like, we've been focused on the software dependencies, but I wouldn't be surprised to see this starting to pop up in malicious pretend, you know, IDE plugins and things like that. It's the same exact problem.
Where do we go for tools to scan our repositories to look for instances of?
You can come to our booth, or you can scan that. There's not a lot of tooling out there that does this, honestly. You know, we've seen a couple other companies that have started doing it recently, but we've been doing it for a very long time. I think people just didn't understand how prevalent this problem was and the need for it. It's a good question. So the question was, yeah, so the question is more like, are you seeing this across all repositories or not? The answer to that is no. There are some things that some ecosystems have in common that make this a sweeter target for attackers. So like in Maven, we have a strong namespace system that was built in, right? And so you can't publish anything to Maven Central using the namespace unless you can prove to us that you own the domain. So that right there makes it very hard for somebody to pretend. Like, you can't easily pretend to be Apache Struts. Why you would want to, I don't know, but you can't do that because you wouldn't be able to be even close to org.apache.struts. You would have to be like Brian's domain.struts, and like, who's gonna confuse that? Maybe it's gonna happen. But so some ecosystems don't have sort of the equivalent of the namespace, and so it's just like component, right? By some component, and so it's easy to fake that. It's component_foo. Well, I can have component-foo. So many ecosystems don't have that, so that right away makes it harder to defend against this, makes it easier to typo squat. The other part of it that I think that kind of makes some of these ecosystems more vulnerable to this is that the tooling by default prefers the latest version. So unless you've locked it down, the default behavior is to grab the latest, whereas tools like Maven, until you tell it to get a new version, it's gonna keep getting the old version. Now that comes with a different set of problems, which is like some of my talks, I talk about the fact that 5 years or whatever it is after Log4j, 30% of the downloads were still of the vulnerable version. So, it's a trade-off. Like one of them prefers stability, which means if you don't update, you're running old code, but the attackers are focused on the ecosystems where they don't have strong namespace and where the default behavior is to grab the latest. Why? It's obvious. I put that thing out there, I get millions of downloads instantly. So they're after the quick hit, right? So for those reasons, it is disproportionate across the ecosystems, but it's not a perfect. It's just sort of put yourself in their shoes. Where would you go first? The one that's easier to fake and the one that's going to get downloads right away.
So you mentioned that some of the products that Sonatype has helps kind of block the execution after it's been validated by the human group.
Yep.
What is Sonatype doing to kind of help the ecosystems all the way upstream to prevent the proliferation of these things?
We report them when we find them up to the ecosystems to get them taken down. That's about the best we can do at the moment. There's some changes here. I mean, Dustin's in the room. Like, you guys made some changes to not do default latest, right? Or at least there was a proposal to change that. Yeah, for the PyPI stuff. Wasn't there a change? One of the ecosystems had started considering a change away from the latest as an example, but maybe it was just a proposal and I was thumbs upping it because I thought it was a good idea. So what we can do is when we detect them, we tell them about it, but where we don't control the policies of what gets published and how the validation is, all I can do is preach what I think should be done, but they don't have to listen to me. So. Any other questions? All right, I told you I'd get you out in time for getting in front of the line. Thanks for coming.